Hello everyone, myself Hiren Patel, associated with LJ Institute of Engineering and Technology. So in this current video lecture series, we are studying subject of Physics Group 1. Till now, in this chapter of laser, we have learned about the properties, the principle of laser. We have discussed Einstein theory, basic terms that used in laser concept, and in last video we have discussed the two types of laser, that is ruby laser and helium neon laser. Now in the current video we are covering the topics such as laser in material processing, laser welding and laser cutting. So let's start with the first topic of today's session, that is laser in material processing. So first of all, you can see in the figure there is a laser source, mirror, shutter, focusing assembly, window, a shielding gas jet and a specimen. So these are the various components used in material processing applications. So let's start the working. So when the laser beam produced from that laser source is passed on the mirror, so that beam is reflected back and it passes through the shutter, which controls the intensity of laser beam and allows it to fall on the focusing lens assembly. This lens focuses the fine beam onto the window and is made to incident on the specimen. So here you can see in the figure that that beam through that window is applied onto the specimen. But here when the specimen gets exposed to the laser beam, it gets heated and it giving rise to the smokes and flames. So it also gets melted. So by blowing the gas from the shielding gas jet, smokes, foams and that molten materials are removed. But as the laser beam is continuously falling on the specimen, the material can be drilled, cut or welded. You can see in the figure that powder spray is used to spray the metal powder onto the substrate for alloying or cladding. So this is the process which is used in material processing. Again I repeat that steps. So when laser beam produced from the laser source is passed through the mirror, so it reflected back and passes through that shutter. That shutter controls the intensity of laser beam and it allows it to fall onto the focusing lens assembly. And through that focusing lens assembly, that beam is forced onto the window and then it is incident on the specimen. So when specimen gets exposed to the laser beam, it gets heated up and it giving rise to the smokes and flames. So it also gets melted, and by using that shielding gas jet, the smokes, foams and molten materials are removed. But as the laser beam is continuously falling onto the specimen, the material can be drilled, cut or welded. Now let's discuss the second application, that is laser welding. So here laser welding, the laser beam is focused onto the spot where two or more pieces are to be joined or welded into the single unit. So here you can see in the figure, here that laser beam is focused onto the spot where two or more pieces are to be joined. So due to the high heat generated by the laser, the material melts over a teeny area on which the beam is focused. Since the heat produced by the beam is so intense, the impurities in the material such as oxide that float upon the surface, and upon cooling the material within becomes homogeneous. Now when it cooling down the material, it becomes homogeneous solid structure which make it a strong joint. There are some advantages of this method. This welding result is consistent and reliable. It is faster welding and high production rates. Narrow welds with controlled bead size is also possible. Now there are some applications that carbon dioxide laser or CO2 laser are used for welding thin sheets and foils. Two dissimilar metals can be welded using this method, and at last it can be done in inaccessible areas like inside a glass envelope. Now let's move towards the last application, that is laser cutting. So somehow it is similar to that welding process. Here when a high power laser beam is focused at the surface to be cut, it melts the material. So the laser focusing part is surrounded by a nozzle into which oxygen is passed. You can see in the figure, when the laser heats up the material, it interacts with the gas and that gas gets combustion, and this combustion burns the metal and thus reducing the laser power requirement for cutting purpose. The oxygen jet can be used to blow molten material. So it is the laser and not the burning gas which controls the accuracy of the cutting. So the cutting rate gets increased when oxygen is used. It is used in the cases where oxidation of age is allowed. So here nitrogen or oxygen can be used to cut the materials like paper, wood, plastic, etc. So there are some advantages of this laser cutting, that it has high precision, high quality edges, no physical contact between workpiece and cutting tool. It is good advantage of this laser cutting method. There are some applications of this method. It is used to cut plastics and ceramics. It cut stainless steels, nickel, alloys and other metals. It is used to cut all types of metals including carbon, aluminum and superalloys. So this is the laser cutting method. So in this video we have discussed the application of laser in material processing, welding and cutting. So now in the next video we will start a new chapter, that is waves, motion and acoustics. So in that chapter of wave, motion and acoustic, we are going to discuss the various type of motion, that is simple harmonic motion, damped harmonic motion and forced motion. And also we will understand that sound reverberation, acoustics of buildings and some remedies of that acoustics of building. So that's it for today's session. Thanks for watching.